All right, guys, we'll finish up our conic sections by talking about parabolas. As always, we give you the definition as kind of the set of points, in this case, a parabola, that are equidistant from a fixed point. We're going to call that the focus again, just like all of our other conic sections, and a line that we're going to call the directrix. Okay. All right, so let's give you a visual of what a parabola looks like. You guys have known for a long time what a parabola looks like. You've been working with it usually in one of two types of equations, vertex form or standard form. Quadratic, like a quadratic form where you have a, b, and c, negative b over 2a, all that good stuff, okay? We're going to give you a little different peek as to kind of a little bit more advanced way of thinking about a parabola, because we're going to have parabolas that not only open up and down, but we'll also talk about ones that open left and right, okay? But I do want to get back to that definition here. Any point on a parabola would be equidistant from the focus, which we're calling F here, and this line. This is the directrix. All right. So these two segments, the distance from any point on this parabola to the focus and the distance to the directrix, would be the same. And just like all other of our conic sections, our parabolas have general equations. Okay? And here they are. If we have x equals and the y variable is squared, this would be a parabola opening either left or right. If it is y equals, with our x squared, what you guys are used to from previous years, because we really only have dealt with functions in the past, a horizontal axis parabola is not a function. It would fail the vertical line test. We haven't talked about those a whole lot, but we do now. That's going to open up and down. Y equals with the x variable squared. Okay? As always, that h comma k is going to be important for us. It is the center of an ellipse and a hyperbola. It is the vertex of our parabola. Okay, so the number added or subtracted to the y would represent the y coordinate of the vertex, whether it's the number added or subtracted to the x, and then the number added or subtracted outside. Okay, so we've got our horizontal movement and our vertical movement. All right, the vertical movement would always be attached to the y or by itself. The horizontal movement either attached to the x or by itself. Okay. And then we have this 1 over 4p term out in front. So there's going to be a number. It might be a 1. It might be something else like 1/2 here. Okay. Whatever number that is, it represents 1 over 4p, where p is the distance from the vertex to both the focus and the directrix. Okay. So we're going to be setting these numbers equal to 1 over 4p, solving for p, and that's going to help us graph our parabolas. All right, let's go straight into an example here. Identify the focus and directrix of the parabola given by x equals 1/2 y squared. First thing I want to do is figure out if this is going to go open up, down, left, or right. We have a singular x equals y squared. This is going to be horizontal. The 1/2 is positive, which means this is going to open to the right. Okay. The vertex, there is no number added or subtracted to the y inside of the square. There is no number added or subtracted out front of the y. The vertex here is going to be 0, 0. Now to find the focus and the directrix, now that we have the vertex, we want to figure out what p is equal to. Okay? And we have the number attached out front multiplied by our squared variable that we referred to back in the original form. We're going to take this and we are going to set it equal to 1 over 4p. Okay? We do a little cross multiplication if we want to. You guys might be able to figure this out just using some math. We've got 4p equals 2. We get p equals 1/2. So that's going to be the distance from the vertex to the focus. So, right, if this is a horizontal right-facing, right-opening parabola, okay, the focus is going to be on the right side of the vertex. The directrix will be a vertical line on the left side of the vertex. And they are both going to be a distance of p away. What is p in this case? It's 1/2. Okay. So let's draw our vertex, our focus, and our directrix, and then we'll figure out how we want to finish up graphing. So our vertex is going to be at 0, 0. Okay. Our focus is going to be right there. Our directrix at the line x equals negative 1/2. The focus at the point 1/2, 0. Okay. So we've done everything they've asked us to do other than graphing those other 4 points here. Okay. Now, we could do this just by plugging in some values, making a little table of values. That's really how I would suggest. We already have our 0, 0 point. Okay, we know that we're going to want x values to the right of 0. Okay, what x values might be good to work with? Well, it would be x values that end up giving us a whole number when we end up multiplying both sides by 2 and then taking the square root. All right, so the first one would be at x equals 2. So if I plug in x equals 2, I get 2 equals 1/2 y squared. Multiply both sides by 2, I get 4 equals y squared. Take the square root, and we're not going to forget that that would give us a plus or minus. All right, so not only do we have 2 comma 2, but we should have 2 comma negative 2. Let's put those on the graph. Sorry, I think my the work was off the screen. Just recap real quick. Plug in a 2 for x. Algebra, we get plus or minus 2. So 2 comma 2 and 2 comma negative 2. All right, good. The next one that would make sense for us here would be 8. So if I plug in x equals 8, I get 16 equals y squared. I get plus or minus 4. All right, after getting the plus or minus 4, okay, we have our 8 comma 4 and 8 comma negative 4. I took the liberty of plotting those points here for us. 2, 2, 2, negative 2, 8, 4, 8, negative 4. We've got our parabola, and now we get to recap. Okay, so how did we graph this? Back to step 1, we saw that it was an x equals y squared parabola. We knew that meant it was horizontal. The leading coefficient was positive, so we knew it was facing to the right. We also knew that would put the focus to the right of the vertex and the directrix to the left of the vertex. All right. We noticed that the vertex was 0, 0 because there were no numbers added or subtracted anywhere here. We then took the coefficient of 1/2 and set it equal to 1 over 4p. Solved for p, that gave us the distance from the vertex to the focus and from the vertex to the directrix. That allowed us to get the actual coordinates of each. 1/2, 0 for our focus. The directrix is a line, a vertical line here at x equals negative 1/2. We then needed to graph. We put the focus, the vertex, and the directrix on our graph, and we plugged in some nice clean numbers for us that got some nice clean numbers out front. And we'll do some more examples of parabolas in class.